Hey guys, today we'll be discussing problem number 3 in today's contest. Let's get started. Okay, so yeah, so the problem says that we have an array and we want to transform one array into another such that we can pick any subarray and place that subarray anywhere we want. Okay, so that's basically the problem. So for example, right, let's take a look at this example 3 1 2 1 2 3. So we can pick 1 2 and put that in front of this 3 to get 1 2 3 in one operation, right? And similarly, yeah, you can do 3 operations on this, transform into this. And the good part about this problem is that the constraints are really small, so you can essentially just brute force, right? So how do you brute force, right? Um, so brute forcing is basically picking first. We need to decide the length of the subarray that we want to choose. Then we want to decide from where it should start, right? So length, then j is your starting index, right? And then we should decide where we want to place it, right? Which is k, where to place it. And after you're done deciding these parameters, you need to construct that array, right? So for example, let's say this was your array and the length that you decided was this one, which was L, right? And j also, this is your j, and the k that you decided was this, right? So after choosing this chunk, what your new array would look like is this L length block over here, right? This is still your k position, this is k plus 1, right? And till length L, and then the remaining part of the subarray, right? So depending on these 3 parameters, you can brute force. So length can go till 6, this j can go till 6, and this k can also go till 6. And also additionally, the construction of this array can also go till 6, right? It's basically O of n. So your total, like, complexity wise, it would be like n raised to 4 kind of thing. Okay, so yeah, so now we know how to brute force, but we still don't know how to transform the array, right? So how to go from nums1 to nums2, how to do that. So since we have all the states, we can use the BFS pattern, right? So basically what BFS would do is that once you have an array, so let's say from nums1, right, you got some intermediate state nums, let's say nums1 dash something, right? So let's say you transform this in one operation only. So basically picked any one subarray and then went to nums1 dash, right? So number of operations to reach nums1, so you might have done a lot of operations, right, on the way. So number of operations to reach nums1 is, let's say, k, and then number of operations to reach nums1 dash is k plus 1, right? So this is kind of a BFS problem where we don't know where we are going, but we have a target state in mind that we want to reach nums2, and as soon as you reach nums2, you can just return the answer, because BFS ensures that you always reach the target state in a minimum number of moves, right? So you can maintain a visited array. Now visited is like if you visited the current vector or not, nums1. So it's hard, like you cannot have a map, let's say a map of vector, right? This would be slow. So instead what you can do is you can encode this, you can encode the nums1. So instead of having a vector, you can have a string, right? So nums1 is, let's say, 0 2 3 4 1. Okay, this is nums1. So as a string it would look like 0 2 3 4 1. So this would serve as your node in the graph, as your state, right? So this is how you can implement visited. And distance is also pretty straightforward, you can just have it in the queue. So I'll just go to the code now. So that's what I've done. So just put a queue of pair of vectors, right? So first vector is the state that we are at, and the second one is the number of moves it took us to reach that state. This visited I explained already. Encode is the function where we convert the vector into the string, right? And then for the first state, we are at nums1 and we essentially did 0 operations. Initially it's set to true, and then just do the BFS thing. So let's pop the current state. This is the logic. Take L, take J, take K, right, and construct the array. So pref is basically the array that we have constructed, and if pref is equals to nums2, just return d plus 1. So d is basically number of moves it took us to reach the current state, right? So plus 1 because we made one more jump, and an edge case would be k equals to j, this case. So if we are trying to insert the sub array in the same position that it was before initially, so that case we can skip, right? So k is basically the position at which you want to insert. J is the position from which the sub array starts. L is the length of the sub array. Okay. Yeah. Construct the prefix, insert the sub array, construct the suffix, check if it's there. If it's not there, then encode it. Encode the current array. If it's there in a visited, if it's not in a visited, then yeah, set it to true and just push that state. Okay. And at the end, since it's guaranteed that nums2 is a permutation of nums1, we will always have an answer. So if you don't have an answer, we just return -1, but this line will never be reached. Okay, cool. Thank you guys for watching. If you have any doubts, please feel free to comment. Thank you.